First of all, girls, if I have 1 over minus 4, that's less than 1, yeah? Yeah? Now, if I multiply this minus 4 across, this becomes this, doesn't it? No, I know, but like it becomes that, doesn't it? Like if I multiply minus 4 across, this is what you get. That's false, isn't it?
Yeah.
Yeah? Because 1 is not less than minus 4. The point I'm trying to say is, girls, just like this, when you have an inequality and you want to solve for x, you can't just simply multiply that across because that bottom denominator can be a negative value. Does that make sense?
Yes.
Yeah? So, how do I avoid that? This is a technique. What you do is you multiply both sides, and I want to ask you girls why. You multiply both sides by the square of the denominator. This is the part I want you girls to ask yourself why. Think of the same question here. If I multiply both sides by the square, if I multiply both sides by the square of the denominator, if you multiply the square of any negative number, what does it become? Positive, right? Yeah? So when I multiply both sides by a positive number, it guarantees me that this inequality sign will not change. Does that make sense? So that's the technique you got to do if you have x at the bottom times by the square of the denominator to both sides. The reason we do it to both sides is because it's got to be equally balanced on both sides. Okay? So now it's just all algebra work. So once I've done that, as you can see now, I can cross off that and the whole thing here. Is that all right? So now we're left with x minus 2 is greater or equal to minus 1 or just minus x minus 2 squared. And then just bring that to the other side and just solve it. Okay? So if I bring that to the other side, it becomes plus x minus 2 squared. And that is now greater or equal to 0. There's nothing left on this side. Expand and simplify that. So x minus 2 plus x squared minus 4x plus 4 is greater or equal to 0. And now I've got x squared minus 3x plus 2 is greater or equal to 0. And this goes back to the same exercise you did in the previous exercise. Yep, solving quadratic equations. Do I need to go through or do you guys know what to do from here? Can I just leave it here?
Yes.
Okay, this is your previous exercise, so I'm just going to stop there. Solve for x, but that's how you do it if you have a denominator. All right? So just same thing. It can be any letter. You all right? Both sides by the square of the denominator. So that's just 2b. Yeah, what do I do now? Yeah. And once again, it's always going to be quadratic, so you know what to do from there. Same thing from previous exercise. What do you do though then if you have two denominators on both sides? It's different. Here's another technique. If that's the case, you bring that whole fraction to the other side. So, girls, this is what I'm going to write. Does that make sense? Okay, this is just the easiest approach to do it when you have two fractions. You can do this approach with this question as well. I could have taken minus 1 in the beginning to the other side and did plus 1. Same thing, but it's just more convenient if you do that method for that type of question. But with two fractions, that's the most convenient. And then what you want to do is now combine them together like two algebraic fractions. So in order to add these two, I've got to know the denominators of each fraction. So what do I want to do? Factorize it, yeah? So factorize it to see what denominator each fraction needs from each other. This is difference of two squares. Okay, so we've got this. So now we can see as one fraction, the denominator is going to be x, x minus 1, x plus 1. Those are the common ones. This fraction needs that, minus, and this fraction needs just x. Right. So if I simplify this, I get this. And now, even if you have something like this, now this is the part where it takes us to what we did in the first question. Now you've got to multiply both sides by the square of the denominator. Square everything, this, and this. So x squared, bracket x minus 1 squared. And then further, x plus 1 squared. So it's, as you can see, it's going to be quite a lot of algebra work. On this side, obviously, you've got to multiply the same thing to the other side, but it doesn't matter what I multiply on this side because anything times 0 is 0, so that's gone. So all you need to do now is, so simplify this bit. It's not that bad. So what do I do? What? Yeah, you're just crossing things out now. Gone. 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 So what do we have left? X minus 1, x plus 1 is greater than 0. And this is a question, exercise question you've done in Fitzpatrick from the previous lesson. Yeah? It's a cubic graph. You draw the cubic graph out and then you get the inequality. Remember that? All right, we got that. And we learned to show it's an odd function. All we need to do is substitute. Minus x. Look good. Let's do that. So I've got minus x on top. I don't like that minus sign. There you go. Yeah, and as you can see, everything stays the same except the top with the minus. And as you can see, this is odd. If you want me to make it more explicit, it's like me doing this. Remember, everything inside the bracket has to be exactly the same as the original, as long as there's a minus outside, and we can see it is odd. So we've proven it's odd. Now let's have a look at the next question and see why they want us to actually use this fact for the next question. If something is odd, girls, all you need to do is see this section, reflect it on the top side, like this. Yeah. Now, see this asymptote 2? On this side, you've got minus 2. And see this positive hyperbola-looking graph? It's reflected on the bottom side of the other side of the x-axis. With odd, if you want to complete the graph, you just reflect it on the opposite side of the x-axis. So if something's at the bottom, reflect it on top. Something's on top, reflect the bottom. Now, having a look at this question, you might be wondering, well, can't we just use the same method as what we've been doing here, just multiply both sides by the square of the denominator, which is instantly what I did at first as well. And I will do it just to show you why you actually can't use that method in this case. Do you see the problem? It's not like what we had here. Because you know how you're supposed to come with an equation where you can factorize and graph it out, then get the inequality like last lesson? You can't do that with that here, as you can see. I mean, we haven't learned polynomial division, which is a method for us to try and factorize that. But just look at this. I don't want to go through that. That's why they want you to use a graph. And here's how you use the graph. Girls? All right. Stuck. We're stuck. So going back to the graphical method, and you actually should know how to do this. Girls, this question means this is the graph. We are going to look at part of the graph that is less than 1/3. Now, when I say 1/3, what value is 1/3? Y equals to 1/3 or x equals to 1/3? Y equals to 1/3. So on the y-axis, let's just say 1/3 is here, right? All right. So graphically, what they want you to do is, I'm just going to just draw a dotted line here. They want you to know, just focusing on, okay, if it says less than 1/3, are we looking at above 1/3 or below 1/3? Below, that's right. So they want you to know, they want you to figure out what x values are these that I'm drawing in purple under the x-axis, including that. That's what they want you to figure out inequality-wise. Do you see what they're asking now? Yes. Okay, so that's our job. All right, I'm going to start with the obvious one. Let's have a look at that side. For this part of the graph, can you see from minus 2, anything less than minus 2 is what this graph can take? Yes. So what can I write in terms of x? X is less than minus 2. Good, so this is that part done. Yep. Now, this is the part where it's a bit problematic. We've got that basically from here, from that x value, which we don't know, to x equals to 2. So this graph is basically, can you see that? We've got some x value in between that and, oh, we know what this part is. What is it? 2, that's right. We need to, how do I figure that out? Now, that's my initial mistake. I thought you had to actually sub in 1/3 in that, but that does not make sense. This is y equals to a third. This is y equals to a third. This is not x equals to a third, so I can't sub it in. So what do? You solve for x from here. You solve for x. So what do I mean by that? Just treat this like just like a normal question like this. You want to find out what the x values are when y equals to a third, like that. Well, how do I do this? Just cross multiply. Yeah, are we good? Now, I'm not going to do the working out. If you go from here and factorize into 2 brackets, what you'll find is actually x minus 4, x minus 1. What does that mean? This is what? Oh, wait, sorry. Plus 1. Sorry, so plus 1. So what does that mean? Minus 1. So this is the number in between minus 1 and 2 for this part of the graph. But what's this? What does the 4 represent? Right there. That's right. 4 right there. So how can I describe this part of the graph? X is... all these values of the graph are in front of 4. So x is greater than 4. Those are your answers. And that's how you get the answers graphically if you can't do it algebraically. And you should know how to do that as well for harder questions in the future. Does that make sense?